Okay, the function f, so f is differentiable. All right, then I look up and notice that this is the graph of f prime. I'm going to actually put an extra note there so I don't forget. The interval, -6, so yep, I see that. 1, 2, 3, 4, 5, comma 0, that makes sense. And I have f of -2 is equal to 7. Now, again, got to make sure I keep track that this is f prime. So this value, f of -2 equals 7, is not on this graph. Right here, when x is equal to -2, on the f prime graph, the x-coordinate is 0. So this is f of -2, f of -2 is 7. Graph of f prime, the derivative of f, consists of a semicircle, 3 line segments. Okay, good. Find the values of f of -6. Okay, I remember that if I'm here, f prime, I have this graph of f prime, and I'm trying to get a value of f, because I want to find f of -6. That's the fundamental theorem to go here to here. Sometimes I use the SASSY method, but that's only if the formula here has the output variable, so I'm not going to do that. So I'm going to use the fundamental theorem. So I have that from my golden notes. And so using that, I'm going to write, let's see, if I integrate f prime I know the value of f when x is -2. I'm trying to find the value of f when x is -6. So if I go from -6 to -2, this will be f of -2 subtract f of -6. Crucial that you note this is f prime, this is f. So now rearranging, we're going to find that f of -6 must equal f of -2 subtract the integral from -6 to -2 of f prime. F of -2 is right here. That's 7. So f of -6 is going to equal 7. Subtract the integral of f prime. So I start over here at -6. I integrate to -2. So all of these values of f prime are positive. So all of this area counts positively. This is 1, 2, 3, 4 by 2, which would be 8. Half of 8 is 4. So this is 2 times 4 divided by 2 again. And I can actually stop right there. If you kept going, you would end up with a value of 3. That will be, let me check the scoring guide. So, actually 2 points for that. They gave 1 point if you remembered that in the process of finding f of -6, you had to use the 7. That was 1 point. And then you got a second point for getting the complete value for f of -6. So that's another point here. So 2 points total so far. To find f of 5, exactly the same process. So I'm going to copy this page over. That off. So I'll have, let's see, the integral from, this time I'm going to start at x equal negative 2, go to 5. So then I'll have f prime, again using the fundamental theorem, that's going to equal f of 5, subtract f of negative 2. Rearranging, we get f of 5 is going to equal f of negative 2 plus the integral this time, negative 2 to 5 of f prime. So f of 5 is going to equal 7 plus, okay, starting at x equal negative 2, all of these values of f prime are negative, so all of that area counts negatively. So put a negative right there, put a parenthesis. That is a half circle. So a couple of ways I can do this. I can take pi times the radius of the circle. The radius is 2. Square that. That would be the area of a circle. Divide that by 2 because it's a semicircle. That counts negatively. We're supposed to go all the way to 5. So all of this space counts positively. So that area is 1 times 2 divided by 2. This area is 2 times 2 divided by 2. You actually don't need to simplify, but that does simplify quickly to 2. That simplifies quickly to 1, total of 3. So plus, be careful with the parentheses here. This must count negatively. This must count positively. And that's done. Don't need to do anything else. That's one more point. So 3 points total on part A. If you kept going, you would combine the 7 and the 3 to get 10. Then this would divide to become negative 2 pi. But there's no reason to keep going. So